जो लोग Zoom पे हैं, today we are going to discuss the questions related to the atomic structure, chemical bonding. Okay. Before I go for that, I'm asking the shapes and angles for the different types. Okay. Go ahead. No, 6 bond pairs. Six bond pairs, octahedral, with a bond angle of what? 90 degree. आप 3 bond pair, 1 lone pair. नाम क्या? जी. Excuse me. Yes. 3 bond, 1 lone. Pyramidal. With a bond angle of 107. 107. Next. Excuse me. What about 2 bond, 2 lone? 2 bond, 2 lone. Non-linear with a bond angle of 104.5. 3 bond, 1 lone. No, 2 bond, 1 lone. 2 bond, 1 lone. Yes, bent angular, but the one with 117.5. Next. 3 bond pairs. Trigonal planar with a bond angle of 120. Excuse me. 2 bond pairs. No lone pair.
2 bond, no lone. Linear, 180.
Yes, linear with 180. Okay. Now, please look at this question. What is the most likely shape of the molecule of hydrazine? Pay attention, please. What is most likely the shape of molecules of hydrazine? Sorry? C120. Anyone else? We don't have to look at these angles, how they look like. We have to look at the electron pairs, the bond pairs and lone pairs. And if I tell you nitrogen has 1 lone pair and 3 bond pair, when it has 1 lone pair and 3 bond pairs, then it should be what? 3 bond, 1 lone. What is this? Pyramidal with an angle of what? 107. Abhi humne kiya, okay? Excuse me. What kind of solid contains more than one kind of bonding? Iodine, silicon dioxide, sodium chloride, zinc. Zinc एक metal है, तो obviously इसमें metallic bond होगी. That is the only force. Sodium chloride ionic bond होगा. That is the only force. Silicon dioxide network of strong covalent bonds होगे. Network of strong covalent bonds. So कोई और force नहीं है. What about iodine? Iodine covalent bond and दूसरी force क्या होगी इसमें? Yes, VDW. So 2 types of bondings are there in iodine, and when iodine turns from solid, sorry, it's a covalent bond and simple molecular structure. It's a covalent bond and simple molecular structure. When it has a covalent bond and simple molecular structure, it has 2 types forces: the covalent bonds within the atoms and the simple molecular and the intermolecular force between the molecules. Excuse me. Which molecule has the largest overall dipole? Overall dipole largest किसका होगा? When there is a carbon-carbon or there is a carbon-hydrogen bond, so there is no bond polarity. Okay? No bond polarities. Okay? Right? No bond polarities when there is a carbon-carbon and carbon-hydrogen bonds. So it means it's a non-polar. रह गए ये तीन. Largest overall dipole. In D, this is negative, this is positive, but they cancel out each other. Again, it's a non-polar. So D and A are non-polar. We are left with these two. Yes, answer is B. Because the bond polarity here, the reason is this. Let me explain this. If you have a carbon here, please pay attention. As this side is negative, this is positive, this is negative, and this is negative. So here it pulls, goes back. Okay. Yeah, so actually once you add up these factors, but on the other hand, look at this. When there is a CH3 on this side, so there is no vector that is pulling backward because they all are partial positive and there is a partial negative. So over here, there is a one vector. Let's say its magnitude is 1. In this case, the same vector has a magnitude 1, but two vectors are also pulling it backwards. So obviously, when you add them up, value will be less than 1. On the other hand, there is no one to pull it back. So value is what? 1 only. Okay? So this is the difference that the bond polarities you have to go. Is it clear? Next. What about this? Sulfur forms S4N4 with nitrogen. The structure of S4N4 is shown below. Assume all the bonds are shown are the single bonds. Determine the number of lone pairs of electrons around the nitrogen atom and around the sulfur atom in S4N4. Lone pair of electrons you have to tell G. Nitrogen has 1, 2, 3, 4, 5 electrons. If let's say it makes one more bond with the hydrogen, I'm just considering it for the sake of clarity. So how many lone pairs left? One lone pair is left here, this one. And if the sulfur has 1, 2, 3, 4, 5, 6 electrons, how many lone pairs left? And how many lone pairs? Two lone pairs, and over there? One lone pair. So nitrogen atom has one lone pair, and sulfur atom has how many lone pair? Which bond angle A or B molecule would be smaller? वो कह रहा है इसमें दो लोन पेयर हैं, इसमें एक लोन पेयर है. Which angle would be smaller? Nitrogen has 5 electrons in total. So I completed the 5 electrons. 1, 2, 3, 4, and 1, 5. Okay? And sulfur has 1, 2, 3, 4, 5, 6 electrons. No, this is bonded ना. ये दो तो bond pair हो गए. ये तो bond बना हुआ है ना इधर. और ये भी bond बना हुआ है इधर. So how many left? Pair. 1. Or in this case, sulfur के case में how many left? 2 lone pair, 1. Or what is the angle here? 2 lone, 2 bond. Sulfur के around, what will be the angle? 2 lone, 2 bond is 104.5. What about 2 bond, 1 lone? 107. So which one is smaller? A. Which one जी? Okay, bond के अलावा देखते हैं ये देख. Look at this. You see these two compounds? I can tell you this is non-polar. This is the information which I'm giving you. And I can tell you this is polar. Carbon hydrogen is non-polar always. And this is polar. वो कह रहे हैं, why suggest explanations for the following the close similarity of the boiling points of two compounds? Why these two compounds have a very close boiling points? Both of them are covalent bond and simple molecular structure. So you have to refer to the intermolecular forces. I can give you this hint. So if the boiling points are similar, so they must have same type of intermolecular forces, and their strength will also be the same. That's why. So आप क्या कहेंगे? What about this? You can see the atomic number and then you can see the difference. 6, 12, 15, 18, 6, 9, 9, 18. You know, it has 18 electrons and it has 18 electrons. How do I got to know? I know their atomic numbers. I uses the atomic number. Carbons का atomic number 6 होता है. Hydrogen का atomic number क्या होता है? So 3 plus 3, 6. 18. What about the 6 plus 1 times 3 plus 9?
18.
So what about this? Same number of. So when they have same number of electrons, the strength of DID forces depend on the number of electrons. The strength of VDWs, the one dipole induced, the IDID forces will be. So what is the close similarity to the boiling points of two compounds? Because
Same number of electrons.
Because same number of electrons and hence same strength or similar strength of DID. Precisely you have to tell DID forces. Okay? Why the slightly higher? Up now you have to explain why this one with the even same number of electrons, same strength of DID, and that why? What is the reason? No, yes. When it's a polar, so there is an additional force of attraction. DD. Although the DID strength is the same because their number of electrons are the same. Yes, but there is also DD in the one with this CH3. It contains an additional force, PD, permanent dipole, which is not there in the first one because it's a non-polar. So CH3F has two types of VDW. PD and DID. So DID of the same strength in both, but the additional force in in CH3CF, PD, that makes it slightly higher boiling point. So I hope you are getting it. Whenever you have to give the explanation related to the melting boiling point, you have to refer to the bonding and structure, and then you have to refer to the intermolecular forces if one of them is covalent bond and simple molecular structure. Okay. Look at this. In which change would only the van der Waals forces have to be overcome? Overcome mean finished. Ethanol, I can tell you, has the OH bond. Ice, I can tell you, has OH bond. Carbon dioxide, there is no OH, NH, FH bond. Butane, no OH, NH of any polar bond. All alkanes are non-polar, okay? So what do you think now? In the first one, when ethanol liquid turns into the gas, the forces of attractions that are overcome are hydrogen bonds, correct? In the melting of ice,
Hydrogen bonds also.
what? Yes, the hydrogen bond. And what about carbon dioxide?
Van der Waals.
Van der Waals. VDWs. And what about the last one?
They don't get overcome because they gain energy.
Sorry?
They become a solid. They don't become overcome.
Yes, it's other way around. The forces of attraction are VDWs, but not overcome, developed, formed. Okay? So the option is what? Option is C. Which intermolecular forces can exist between adjacent urea molecules? This is the urea. Urea has NH-OH FH bond. So one of the force is the hydrogen bond. Okay, agreed. This one is correct. Why? Because there is another bond which is polar other than nitrogen-hydrogen bond, which are also polar, but you have CO bond polar. Because of the CO, there are also PD-PD forces.
And so the 1 to 3 on.
And we know that DID is always there. Dipole-induced dipole force is always there for all type of compounds. Here, the diagram shows the example of organic nitrate molecules. Which statement is correct for the bond angle shown in ascending order? The smallest first. Which one? You just assign. Look, let me put the question this way. You have to assign the bond angles.
Then one is one.
Angle बताएं. One कितना है?
109.5.
109.5. Why? Because it is 4 bond pairs around the central atom. 2 is 120 because there are 3 bond pairs around the central atom. 3 is 2 lone pairs are missing. So what is 3? 2 bond, 2 lone should be 104.5. So what is the smallest?
312.
312. This one. You have to identify the coordinate bond, the covalent bond, and the lone pair of electrons in this molecule. You understand the coordinate covalent bond, the bond which is formed by the sharing, just like a covalent, but the shared pair belongs to one atom only. I hope you can identify 2XX.
Then the covalent bond is below the XX. Yeah.
Yes, and where is the covalent bond? Yeah, 1 dot 1 cross. Anyone? I can put them, yeah. The same on the top, I can also. The above this. What about the lone pair? This is lone pair. This is lone pair. So anyone you can mark. Okay? Yeah, one more thing which you have to understand. I think you should write it in your notebook as well. Please write down. If there is a triple bond between carbon and oxygen, and there is a triple bond between nitrogen and oxygen, right? Just 1 minute. And you know they have same number of bonds, similar bond strength, but you know nitrogen is inert, but carbon monoxide is reactive. Why the case? Both have same bond energies even. Why the case is like this? Because due to the difference of electronegativity, carbon monoxide is what? Polar, having dipoles. So dipoles can attract positive negative ions, which makes it reactive. Nitrogen is what? Non-polar. So bond polarity is also linked with the reactivity. Okay. So bond polarity also creates the reactivity or also makes the compound reactive. Okay, next. बस आने वाले हैं. But I'll give the introduction in the end. And look at this, just 5 minutes. ये last challenge question कर देते हैं. Aluminum chloride sublimes at 178 degree. Which structure best represent the species vapor at this temperature? I mean, aluminum chloride turns Al2Cl6. कौन सा वाला होगा? Yes, A. Why? Because there is a one aluminum chloride here. And there is another aluminum chloride here. Right? So these two are bonded together. How they are bonded together? You see the dative covalent bond formed between first and second, and dative covalent bond formed between this and this. So this is how they make Al2Cl6, right? This one. The diagram shows the variation in the boiling point of hydrogen halide. You see hydrogen fluoride, chloride, bromide, and iodide, which explain the higher boiling point of hydrogen fluoride. Yes. There is a hydrogen bond between the molecules of HCl. Here it is. We have to look at draw the diagram to show the shapes of SO3 and Cl2O. Kya hogi? Can you please do it? SO3 and Cl2O. Sulfur is in group 6, I can tell you. Oxygen is in group 6, I can tell you. Sulfur trioxide has what dot and cross? You always need to draw dot and cross, bacho, for the sake of clarity. And then you have to see what type of bond pairs and lone pairs are there. And then you decide the shape. So what is the bond pairs? In determining shape, double bond is considered as one bond pair. 3 bond no lone. When there is a 3 bond no lone, what should be the shape? In this case, you have to draw the shape. This dot and cross is the additional thing which I did here. So when they ask you to draw the shape, you have to draw the shape like this. Okay? Yes. What about Cl2O? Why? 2 bond. These are the 2 bond pairs. And 2 what? Lone pairs. So 2 bond, 2 lone is non-linear. You have to draw the shape like a non-linear, okay? I think this question we did yesterday, SiO2 and SO3 wala. This one. Explain in terms of structure and bonding why melting point of SiCl4 is much higher than NaCl. Much lower than NaCl. SiCl4 is simple molecular covalent bond, simple molecular structure, but you have to hit the original point which give you the mark. That's why it contains weak forces which do not need a lot of energy to break. On the other hand, NaCl has an ionic bond at giant ionic lattice. Yeah, you have to mention the name of the force. You can't write IMF, intermolecular forces. And what about this? Giant ionic lattice. Yes. Okay. Yes. Okay, now this is the look at this. Copper. What is the type of bonding? Sorry? Metallic. And type of ice? Covalent. Lattice. Silicon dioxide. Lattice. Macromolecular structure. Iodine. Covalent. Sodium chloride. GIL, giant ionic lattice. Strongest intermolecular force of ice. Hydrogen bonding. Draw fully labeled diagram. 2 water molecules in ice, 2 water molecules. So you have to draw fully labeled diagram. This is partial negative, 2 lone pairs, partial positive, and then this is hydrogen. Look at this. This is partial positive. Yeah. What is this force then? Hydrogen bond. Okay. Okay, right. Okay, now we have to come to end of this. This is the sigma and pi bond. That is the part which we'll be doing in organic chemistry. Now we are going to start the next organic chemistry. Okay, so please give heading organic chemistry. वो करेंगे. Yeah, after organic, yeah. Okay, so organic. Okay, please pay attention. Pay attention. Okay, bachcho, in organic chemistry, if you look at, I'll give you the introduction, the brief one. It is the chemistry of carbon containing compound. Previously, आपको पता है इसकी definition was not this. What was the first definition? The first definition was the compounds which are obtained from living organisms, the living things like plants, animals, human beings. So जो compounds इनसे बनते हैं, they were organic. और बहुत अरसा we have been thinking कि okay, these are the compounds which we cannot prepare in the lab because living things we cannot prepare in the lab. So बहुत अरसा हम ये सोचते रहे कि only those compounds are the organic compounds. But later on we then figured out, that's not the case, and then we redefined it. And finally, we come to this conclusion that all those compounds which contain what? Carbon as an essential element are known as organic compound. But again, there are few exceptions which does contain carbon, but they're not organic compounds. What are those exceptions? Carbon dioxide, carbon monoxide, carbonates, hydrogen carbonates, and cyanide. So please write down carbon containing compounds right, except carbon dioxide, carbon monoxide, carbonates, hydrogen carbonates, and cyanides. Okay, so these are although contain carbon, but they are not organic. Okay, other than this, whenever you see carbon, you know it's an organic compound, right? So other than this, they all are organic compounds, right? Carbon containing compounds, which are known as organic compounds, right? For example, CH4, C2H6, C3H8, C4H8O2, C3H6O, etc., etc., etc. Okay. Before we start them formally, we know that if you look at the classification, because that gives you an idea. No, classification mean मैं syllabus बताने लगा. I'm going to tell you the syllabus which you are going. So classification of organic compound, they are divided into two main parts. एक होते हैं जिनको हम बुलाते हैं what? Hydrocarbons. जिनमें क्या होता है which contain carbon and yes, carbon and hydrogen only. जैसे if you look at the first line which I gave the example, they are the hydrocarbons because they are the compounds, na? So carbon के अलावा भी तो there must be some element. So that element should be hydrogen only for the hydrocarbon, right? And then for the others, at this moment, if the other element is let's say carbon hydrogen के साथ oxygen आ जाता है, right? So CHO, it must be it could be an alcohol. This is an example of other than hydrocarbon containing carbon, hydrogen, oxygen. It could be carboxylic acid. Yes, it could be ester. These are the ones which we did in O level. And there are two more. They are known as aldehydes and ketones. Okay. Similarly, the others may have carbon, hydrogen, oxygen, and just let's say nitrogen. And the one example which I'm going to write it here is proteins, and so on and so forth. So I just wanted to give you an idea. And these hydrocarbons are actually divided into two parts. Look, One is called saturated hydrocarbons, and the other one is known as unsaturated hydrocarbons. Okay, so saturated hydrocarbons mean containing carbon-carbon single bond, and unsaturated mean containing carbon-carbon double or carbon-carbon triple bond. A triple is not in our syllabus of ES chemistry, so it is A2 में भी नहीं है, right? So this is, and the example for this is alkane, and this is alkene, right? So this is what I wanted to tell you, the syllabus actually. So this is the syllabus which we are going to study. We are going to study these group of organic compound: alkane, alkenes, alcohol, carboxylic acid, ester, aldehydes, ketone, and proteins. So these are the organic compounds which we are going to discuss. So we are going to start with the first one. What is the first one? The alkane. So give a heading alkane. Chalo, we'll start tomorrow. So alkane is the first group जो हम discuss करेंगे. First we'll discuss the naming, then we'll do the isomerism, and then we'll go through the reactions. Okay, right? Thank you. Allah Hafiz.